So think about this. Every single time you download a file, or get a software update, or receive a secure message, how do you really know it's the real deal? How can you be sure that what you're getting is exactly what the sender intended without even a single bit getting changed along the way? Well, the answer lies in something called a unique digital fingerprint. And today, we're going to dive into one of the fastest and most secure fingerprinting tools out there, Blake2b. Let's dig a little deeper into that. Say you're downloading a massive file, like a new video game that's dozens of gigabytes. How does your computer check, in literally seconds, that the file is perfect, that it wasn't corrupted on its way to you, or even worse, tampered with by a hacker? I mean, you can't just download it again to compare, right? That would take forever. This is exactly the puzzle that these digital fingerprints, which we call hashes, are built to solve. So what exactly is a hash? You know, the easiest way to think about it is like a super advanced blender. You can toss in anything, a tiny text file, your entire photo library, a full-length movie, and it grinds it all down into one unique, fixed-length code, a digital fingerprint. If you put the exact same file in 1,000,000 times, you'll get the exact same fingerprint back 1,000,000 times. But, and this is the absolute key, there's no way to reverse the process. You can't take that fingerprint and rebuild the original file. It is a one-way street, period.
Okay, so the fancy term for this is a cryptographic hash function. It's really just a mathematical recipe that takes whatever you give it and turns it into a neat string of characters. And the output is always the same size, no matter if you started with the word hello or the entire Library of Congress. The two things you got to remember are fixed-sized output, and it's totally irreversible. It's like trying to unscramble an egg. Good luck with that.
All right, clever stuff, but so what? Why should you care about this one-way function? Well, it turns out this little idea is one of the absolute pillars of our modern digital world. Seriously, these digital fingerprints are everywhere once you start looking. Ever seen a checksum when downloading a file? Yep, that's a hash. It's checking to make sure the file didn't get scrambled. The whole world of blockchain and cryptocurrencies, it's built on a foundation of hashes. Digital signatures that prove a document is authentic? You guessed it, hashes. Even your cloud storage is using them behind the scenes to save space. They hash your files to see if someone else has already uploaded the exact same thing so they don't have to store it twice. Pretty clever, right? But, and this is a big but, not all fingerprints are created equal. Just like a cheap lock can be picked, a cryptographic algorithm can eventually be broken. As computers get more powerful, the old ways of doing things just aren't safe anymore. Some of the classic algorithms, names you might have heard of, like MD5 and SHA-1, well, they're toast. They're officially considered broken. And broken means something very specific and very bad. It means a hacker can now create two totally different files that have the exact same digital fingerprint. This is called a collision, and it's a security nightmare. Think about it. What if a virus could be engineered to have the same fingerprint as a critical software update? Your computer would check the fingerprint, think it's legit, and game over. This is precisely why the world needed a new hero in the hashing game. So with the old guard failing, the experts went back to the drawing board. And what they came up with is the star of our show today. Let's meet Blake2b. The official document that defines it says it all, really. Blake2b was designed from the ground up for speed, simplicity, and rock-solid security. They knew they needed something that could handle modern threats, run lightning fast on today's computers, but without cutting any corners on safety. So what are its superpowers? Well, for one, it's fast. Like, really fast. It actually outpaces its main rivals, SHA-2 and SHA-3, on most modern hardware. It's also built on cryptographic ideas that have been tested and proven for years, so it's tough as nails against known attacks. And get this. Its design is actually quite simple, which in the world of security is a huge plus. It means experts can easily audit it and be confident that there are no hidden flaws. Okay, so it's fast, it's secure, we get it, but how does the magic actually happen? Let's pop the hood and take a peek inside the engine, or maybe it's more like a cryptographic mixer. So here's the basic recipe. First, the process kicks off with an internal state, which is just a bunch of predefined numbers. Then it takes your data, that file you want to hash, and chops it up into neat 128 byte chunks. And here's where the real action is. It takes each chunk one by one and uses it to stir up and scramble that internal state. It's like adding ingredients to a blender. Once the very last chunk has been mixed in, whatever that final jumbled up state looks like, that's your hash. Now that vigorous mixing part, that's the secret sauce. And it's all powered by a surprisingly simple, yet incredibly powerful process known as RX. ARX, it stands for add, rotate, and XOR. That's it. These are three basic operations that a computer's processor can do in its sleep. Add, you know what that is. Rotate just means taking the bits of a number and shifting them around in a circle. And XOR is a fundamental bit-flipping operation. The thing is, while each one is super simple on its own, when you combine them and repeat them over and over, you get this incredible chaotic complexity. It's the perfect way to build something super secure out of simple, fast parts.
And here's the crucial bit. Blake2b doesn't just do this ARX dance once. It does it again and again and again in a series of rounds. This constant mixing is what creates something cryptographers call the avalanche effect. It means that if you change even one single bit in the original file, just flip a 0 to a 1, the final hash will be completely wildly different. It's a total cascade. And that is the heart of its security.
Okay, so we've seen why we need this stuff, and we've peeked at how it works. Now let's bring it all home and see why Blake2b really is the modern champion of this field.
So let's just lay it all out. You've got the old guys like MD5. They were fast, sure, but they're broken, useless for security now. Then you have the other modern secure options like SHA-256 and SHA-3. They're totally solid, but they're kind of slow. And then there's Blake2b. It's sitting right in that perfect sweet spot. It gives you the bulletproof security you need, but at speeds that feel like the old, insecure days. You get your cake and eat it too. It's really the best of both worlds.
So why does Blake2b win? It's simple. It nails the three things that matter most. 1, it's pre-image resistant. That's our one-way street. You can't go backwards from the hash to the file. 2, it's collision resistant. You can be confident that finding two different files with the same fingerprint is practically impossible. And 3, it does all of this while being ridiculously fast. It just checks all the boxes.
So yeah, Blake2b is pretty much the king for right now. It's the perfect tool for our time, balancing speed and security like nothing else. But technology never, ever sleeps. We've got quantum computing looming on the horizon, threatening to shatter a lot of the cryptography we rely on today. So that leaves us with one last question to chew on. In a world of quantum computers, what does the next unbreakable digital fingerprint even look like?